Hey, you guys, happy Monday. Today is Monday, March 19th, 2018, and I'm coming to you from my house because I am feeling lousy. So, quick update, I did run the 5K on my birthday, and I did it, you guys. I ran the whole time, and I didn't think I could. And so I'm super proud of myself, but I'm also slightly regretting it because I think my lungs are mad at me, and I'm feeling not any better. In fact, I'm feeling more lousy than I did last week. So, I'm taking today off to just rest and recuperate and keep my germs at home. And my plan is to be back with you tomorrow. Quick reminder, please be on your best behavior when we have a guest teacher. Um, I have high expectations for you all, and I know that it's hard to be a guest teacher. So please be helpful, please be productive, and please do your job. I'm going to just kind of give you a quick video lesson for the homework that you're going to complete today. And so whenever you're ready, go ahead and take out your green proportions packet and open up to this page. We're actually going back to the very beginning of this packet, and we're going to finish up and do a couple of lessons on similar figures and finding missing lengths on similar figures. So go ahead and pause the video if you need to, and come back when you're ready to fill in just a few notes and do a couple of examples. All right, so this is lesson 7-1, similar figures. Nothing to go in the toolbox. You can fill out the date today. It's Monday, March 19th, 2018. And there's just a few vocabulary words that we need to get under our belts before we can move on. The first word is congruent. This should not be a new word to you, but you may need a refresher about what it means. Congruent means that two things are the same size and the same shape. Basically, they're identical. If you copied and pasted something, a shape, for example, those shapes would be congruent because they're exactly the same size and exactly the same shape. If you want to hop over, click a new tab and Google symbol for congruent. There's a pretty cool symbol that shows that two things are congruent. And if you draw that over here in your notes, there may be a reward for you tomorrow. Take a quick pause if you need to, and then come back for the next word. Next word, corresponding angles. Corresponding angles are matching angles in a similar figure. Along with corresponding angles, similar figures have corresponding sides, and that is a pair of matching sides in a similar figure. Those sides are proportional. They're not exactly the same, they're not congruent, they are not identical, but they are proportional. So we talk a lot about scale factor and using the same ratio or proportion to either enlarge or make a shape smaller so that the sides are still corresponding, but they're not exactly identical to the original shape. And then scale factor. Scale factor, like I mentioned, it is a ratio, and it's the ratio of corresponding side lengths in similar figures. Okay. Excuse me. Essential question number 1, similar figures. What is a similar figure? There's two things that need to be true in order for two shapes to be similar. They have to be the same shape, and they have to have different yet proportional sizes. So when we talk about their corresponding sides, their side lengths are going to be different, but they are proportional. Similar figures are not congruent. Congruent figures, remember, they are exactly the same with the same size and same shape. The difference here is that similar figures are still the same shape, so they look alike, but they are different sizes, and their side lengths are proportional. You can take another quick pause, go back up to Google, and write down, or Google, I guess I should say, what is the symbol that you use for similar figures, because there's also a pretty cool symbol that you can use to show that two objects or two shapes are similar. So pause if you need to, Google that, and then will you draw that symbol right here, because I'm going to be checking your notes tomorrow at the start of class. And then come back and we'll do a couple of examples. All right, so we just talked that similar figures have to have the same shape, but different and proportional size. So these two triangles, triangle ABC and triangle DEF, there's that symbol that you may have just Googled. These two triangles are similar. We can see that because these these symbols within the triangle show that their angles are corresponding, and that means they're the same. So this angle A is the same as angle D, and that's something that's always true in similar figures, that their angle measures are the same. Angle B here that has two arcs is the same as angle E, and angle C with three arc lengths, or three arcs, is the same or congruent or identical to angle F over here on this similar triangle. What else we know about similar triangles or similar figures is that their corresponding side lengths are proportional. So if we take a look at side angle A or side length AB, the distance from A to B is 6. The corresponding side on this similar figure is DE, which has a side length of 9. Notice that they're not the same. However, when we look at the scale factor, we notice that this second figure is exactly 1.5 times as large as the original. And what's going to be true about the rest of the side lengths is that they're also 1.5 times the size. They have a scale factor of 1.5. If we set that up like a ratio, it would look like 6 over 4, and we can simplify that to 3 halves, which is a scale factor of 1.5. 9 over 6 also reduces to 3 over 2, which is a scale factor of 1.5. 4.5, or the length from D to F, is similar to AC, and if we set that up as a ratio, 4.5 over 3, it reduces or simplifies to 1.5, which is a consistent scale factor for this set of similar figures. I'm going to have you pause the video and fill in the rest of this chart for this example as well as for this one. Right now your job is to just identify what are the corresponding angles and what are the corresponding sides. So I started it off for you. Angle A is corresponding to angle D. I know that because they have matching number of arcs, which means they're the same. Side length AB is similar to side length DE, and I can tell that because I'm looking at these angle measures, one arc to two arcs, and that line AB connects the one arc to two arcs, and so I'm looking for that same line in the second triangle, and here's the first one arc and two arcs, so line DE must be corresponding, and I showed that here. To figure out the scale factor, I took the side length from the bigger triangle and divided it by the side length of the smaller triangle and got a scale factor of 1.5. You check the rest, please. What are the other corresponding angles, the other corresponding side lengths, and then what is the scale factor? Pause the video to do that. Also try this second example down here, and then come back when you're ready to check to see if you are on the right track. You should fill in that entire chart. Go ahead and use a calculator if you need to. Sorry, I gotta bounce back here to the key so that you can check your thinking with my thinking. It's going to be important to be able to identify similar figures and corresponding sides because we're going to eventually use that idea of having proportional side lengths and scale factor to find unknown side lengths of a similar figure. So here is what I came up with for corresponding angles and sides for the first example. And example number 2, I noticed that the scale factor is 2 because this triangle is exactly twice the size of this triangle. We doubled the side lengths in each of the corresponding sides. And that's how we get a scale factor of positive 2. Go ahead and try the next 2 examples, which are which is this quadrilateral and then these triangles. When you're done filling out this entire chart, come back and check your answer with mine to make sure that your notes look good. To get you started on this quadrilateral, it doesn't matter where you start. I'm going to start with corresponding angles, and I'm going to start with angle A. That has one arc, so I'm looking for the other angle on the shape over here that also has one arc. Corresponding angles are angle A and W. Corresponding side lengths, AB, which goes from one arc to two arcs, is the same as, or similar to, I should say, side length WX, which also goes from one arc to two arcs. And to identify the scale factor, what kind of multiplicative change is happening to go from AB to WX? Oh shucks, I don't know the side length of AB. All I know is the side length of WX, so I'm going to hold off on that until I check another side length. What about picking two that I know definitely have the side lengths there, like DC and ZY? Here's what I notice. Going from 4 arcs to 3 arcs, 4 arcs to 3 arcs, those sides are corresponding. The scale factor, 15 is one of the side lengths as compared to 10 of your other side length. And if I write that as a fraction, 15 over 10, that can be simplified by dividing the numerator by 5 and the denominator by 5. And we get a scale factor of, again, 3 over 2. 3 over 2 simplifies to 1.5, or a scale factor of 1.5. So using that information, here's what I know. I know that this side length, AB, is also going to be 1.5 times smaller than 24. So I can set up a proportion using that scale factor, and that's what this looks like. If the scale factor is 3 over 2, then this side length, the bigger one, 24, over this unknown side length, I'm going to call X. And now what we've done is set up a proportion. This is kind of a preview to what we're going to do tomorrow, but I want to see if any of you could solve that proportion or solve for X. If you can, circle it right here. You're used to seeing this proportion written up and down. So 3 on top, 2 on the bottom is equal to 24 over X. And then we can cross multiply and divide to solve for X. My voice is fading here. Go ahead and see what you can do to fill out the rest of this chart. Pause, come back to check, and then I'll lay out what your assignment is for today. Okay, so here we notice that the scale factor was indeed 1.5. I needed to add one more row there. And here it was also 2. Excuse me. All right, your to-do list for today, you have three things I should say, that you need to get done. Number 1, you need to complete homework assignment 7-1. Shucks, which is right there. Homework 7-1 is also appears on your Schoology. So after you have finished in your packet 7-1, I need you to sign into Schoology and complete this 5.5 question assignment on 7-1. It's basically taking your answers from the packet and typing them into the computer and submitting them that way, so I can see how well you did on the assignment. Number 2, this practice MCA test is not something that you need to complete today. However, the questions from here are very similar to those questions in your MCA packet that I said was due today. Your second task is for you to finish working through your MCA packet and turn it in to the basket when you're done. Those of you who are already done with that packet and you did your homework, you can be rewarded. And when you're finished with 7-1 in your packet and in Schoology, excuse me, you can read a book or you can play a quiet game. You need to check in with either Miss Roberts or the guest teacher. They need to okay what you've done in your packet, and they also need to okay the game that you're choosing to play. If you have questions, you can feel free to email me. I'll be checking my email throughout the day. If you don't finish this during class, you still have access to it outside of class. Oh man, I'm struggling. And I will check back in with you tomorrow. I hope you have a great day. See you Tuesday. Oh my goodness.